So what I've been teaching you is the unit chain conversion fraction method, whatever you want to call it. And so on your quest, there's going to be 1-step and 2-step questions. You back with me now? Because you're fidgeting. You're back? Okay. Thanks, Gans. Let me just make up some examples. For example, if I said convert 12.5, I'll pick a metric prefix. I'm just making these up. I'm going to go with capital T. I know that's a metric prefix. And then I'll pick a unit. How about grams? Convert that to grams. So again, you can write this down or you can just watch and I can print this up for you, whichever works better. I call this a 1-step question. The reason I call it a 1-step question is we're just getting rid of something. I'm also going to give you a very similar question like this. Suppose I have 419 grams and I want to bring in a metric prefix. I'll say like that. So 1-step questions, Savannah, we're either getting rid of that and leaving with what I call our base unit. By our base unit, I mean just the single letter that tells you what it is. Or you're starting with the base unit and you're bringing in a metric prefix. With me so far? What's the first thing I always do? Write down what they gave me. And I'm doing that on purpose so that I want to remove the whole I'm frozen and don't know how to start thing. So Savannah, what's the first thing I always do? Write down what they gave me. I'm going to write down 12.5 teragrams. In my mind, I'm going to imagine that. Can I erase that, please? And just imagine it. I'm going to multiply by a conversion factor. Teragrams is on the top. Where am I going to put it in my next fraction so that it will cancel? And I'm going to put, because I want to end up with grams, just plain old grams on the top. However, tera, from your green sheet, which you probably should have in front of you, is 10 to the what? It's either 10 to the 9th or 10 to the 12th. Okay? Where does the 10 to the 12th go? This is the key. You don't memorize top or bottom. What you memorize is it goes where this letter isn't. So if that T is on the bottom, the 10 to the that replaces it goes on the top. Now I would go to my calculator. This is probably, oh. The 1 didn't show up, did it? Ha. There. Oh, times 10 to the 12th. This is probably going to give me an answer in scientific notation because it's so big. Oh, it's okay. So I would write not 1.25e, I would write 1.25 times 10 to the 13th. Okay? That's how I get rid of a metric prefix and just leave my base unit. Or I can start with my base unit and introduce a metric prefix. You know what I'm going to do first? Write down what they gave me. 419 grams. And again, I'm imagining it's over 1, but I'm too lazy to write that because you've learned by now, hopefully, that any whole number is technically a fraction over 1. Okay, so I know where there is a top and a bottom. The 419 and the G are on the top. Okay with that? We're going to multiply by a conversion factor. I want to get rid of grams. And I'm going to bring in what I want to be left with. Now, micro, which is that symbol, is 10 to the negative. Okay, where is it going to go? I never memorize top or bottom. I memorize it goes where the metric prefix isn't, which in this case is going to be on the bottom. Now, because it's on the bottom, what mathematical operation am I going to do with that 10 to the negative 6? Yes. See, it's all coming back actually to your grade 5 and 6 math. If I do this right, we'll do it all with grade 5 and 6 mathematics. 419 divided by 10 to the -6. My calculator might give me this one in scientific notation. No, I think this is right around the tipping point. Probably one more 0 and my calculator would have given me this in scientific notation. If you wrote 419 and then wrote 6 zeros, I'll give you full marks. I'm naturally lazy. It's going to be less work to write this in scientific notation. So I'm going to write this as 4.19 times 10 to the, count with me, 1, 2, 3, 4, 5, 6, 7. Yes, I agree, 8. Okay. I also checked next to each of my answers to make sure there were units. If I wrote an answer and I didn't put units next to it, Mr. Dueck is a mean jerk. He'll take a half mark off. He played you a frustrated phone call from a poor person trying to explain to Verizon that units matter. And there's a big difference between being charged 72 cents and $72. Because there's a difference between $0.002 and $0.002 cents. Verizon couldn't get that. You see why I call these one step? Because I needed one conversion factor. I'm probably going to have 2 of these on your quest, maybe only 1. What I'm going to have is several two-steppers. What do I mean by a two-stepper? Not even kilometers per hour yet, actually. That's a two-step. Here's what I mean by a two-stepper. Convert 306. Pick a metric prefix from your green sheet. I don't care. Pick one, Savannah. E? That's a metric. Oh, capital E? Wow. Exa, and then I'll pick a unit. How about liters? And we're going to convert that to, I don't know, megaliters. What I mean by a two-step is you're going from one prefix to another prefix. You're not just getting rid of it. Guess how I'm going to start? Yep. Is E exa? You're using obscure ones, which I like. First thing I'm going to do is get rid of exa. Where's it going to go? Yes. And I'll put just plain old liters on the top. What is exa? 10 to the... Where's the 10 to the 18 going to go? Where the E isn't. That's what I've memorized. Now, that gets rid of exa. This would be if I was in liters. Do I want to stop in liters? I want to stop in mega. So, I want liters to cancel. Megaliters left behind and on the top. What's mega? Where's the 10 to the 6 going to go? So, what am I going to do with the 10 to the 18th? Times. What am I going to do with the 10 to the 6th? 306 times 10 to the 18th divided by 10 to the 6th. And this gave me an answer in scientific notation, 3.06 times 10 to the 14th. Megaliters. That's a two-step. I'm going to give you one that you can try on your own. I won't freeze the screen. We'll just see if we do the same thing or get to the same place. If you're writing stuff down. If you're not writing stuff down, you can just try doing the steps in your head and seeing if you can get the right answer in your head, all on your calculator by visualizing it all. So let's go, oh heck, 4,000 nanoamps. And I want to convert that to milliamps. Okay, and again, don't let amps scare you. That's my metric unit, like grams, like liters, like whatever. I'm only looking at the prefixes, and I'll just tack an A onto everything as I need to. So it's going to be 4,000 of those. Oh, I got my metric prefixes here. Good. Am I right? Yay. that correct, I think? Okay. Since you're here for a tutorial and giving up your free time, I'll even tell you a bit more about the test. I think it's going to be out of around 24-ish, plus or minus a mark. What I'm going to actually do, because I don't want it to count for very much by the end of the year, I'll divide it by 2 and I'll make it out of 12. Or if it's out of 26, it'll be out of 13. The first 4 questions are going to be scientific notation, right in scientific notation. I'm hoping that's pretty close to free marks for you. So I'll give you, you know what, 2 big numbers and 2 decimal numbers. I'll even be that blatant. That would make sense. Right? Then there's going to be some sig figs questions. And probably out of the 24, probably 12 marks, maybe a bit more, will be sig fig stuff. So I'm willing to also go over that in just a few minutes too. Yeah? Yep, we can do that in a second. Okay. There's going to be, I'm going from memory here, I think 5 unit conversion questions, 1 or 2 one-steppers, a couple of two-steppers, and then probably 1 two-step, two-step. And what I mean by a two-step, two-step, let's do one of those. Uh, 13, let me think of something legitimate here. Well, sorry, let's do it this way, Mr. Dueck. Kilometers per hour equals, and let's convert that to millimeters per second. Do you see what I mean by a two-step, two-step? We're going to have to take care of kilometers, and that's probably going to take a couple of steps, and we're going to have to take care of hours. Okay? Now, when I type this, look up for a second. Because I'm typing, this will probably be written as that. Slanty fractions are evil. Oh, and this will probably be written as that. Slanty fractions are evil. You know what? Let's have some fun. Instead of per second, let's make it per microsecond. Okay? First thing I'm going to do is what? Absolutely. And no slanty fractions. They're evil. And now you're starting to see why those bug me so much, because now it's obvious. Where is ours? On the bottom. Where does it look like it is here? Kind of on the, if you're not careful. Okay? We need to do these one at a time. What do you want to get rid of first? Kilometers or hours? I don't care. Pick. You want to get rid of kilometers? Okay. So, kilometers in my next fraction is going to be on the just plain old meters. First of all, I got to get rid of the K. Kilo is 10 to the third. Yeah. And that goes where the K isn't. Then, and I've told you there's a problem because an M in front means milli and an M after means meters. I've gone on my rant about how we only have 26 letters in the alphabet, and so we're going to have to reuse and repurpose some. Sorry, you'll have to figure out the context. So it's going to be meters on the bottom, millimeters on the top, and is milli 10 to the negative 3? And that goes where? Where I don't have the metric prefix. If I stopped here, that would be millimeters per hour. Is that okay, Kens? You're looking a little yep. Okay, right? Top and there, bottom. Okay, I'm going to keep going. I need to get rid of hours. Right now it's on the bottom, so where will hours go in my next fraction? Okay, what can you turn hours into? Have you memorized that? Convenient? It's a handy one to have in your back pocket. As much as I don't like, wait a minute, are you memorizing it because it's a shortcut and you got sick of looking it up? Then that's a good reason to memorize something because it's a shortcut. So yeah, we can go seconds. It's going to be 1 hour is 3,600 seconds, except I don't want to stop in seconds. I want to stop in microseconds. Where is the S right now on the, where is it going to go in my next fraction? And I guess microseconds, which I do want to end up on the bottom, I have to put it down there. And micro is 10 to the negative 6. If you take physics 12, you'll end up memorizing micro in the electricity unit because you get sick of looking it up. So the whole thing is going to be 13 times that divided by, I have no idea what the answer is here. I don't know. 13 times 10 to the third times 10 to the negative 6, and then divided by 10 to the negative 3 and divided by 3600. Did I type that in correctly? I think so. You got that?
Yeah.
So this is right on the threshold of, is scientific notation shorter to write that or not? If there was one more 0, I'd almost certainly go to scientific notation because it's less writing and I'm lazy. Here, if you said 0.0036, fine. I'll go 3.61 times 10 to the negative 3. Now for the unit conversion stuff, we've been ignoring sig figs. Does that help for unit conversion a little bit? Okay. Oh, I'll even give you one. There's probably going to be one kind of a question where I ask you to convert like years to seconds or days to minute or something like that, where you'll have to build a chain, but you know all the conversion factors because you've grown up. You'll just have to build a hopscotching get there chain. Okay. Let's do some sig figs then. Okay. .63 times 2.5719. I'm just making these up. What's the first thing I would do here? Good. So there's two main rules. There's the multiplication division rule. By the way, there's also more rules than that. There is a rule for square roots. There is a rule for cube root. There is a rule for all of the other math stuff that you're doing, but we're not going to have to run into that this year, okay? But if you're wondering, there is. How many sig figs is that? Oh, there is going to be 4 questions, maybe 5 questions, where I just give you a number and I say, how many sig figs? How many? And each of those will be 1 mark each. So I'm building that into here. How many sig figs? What if I had that right there? Okay. Still be 3? Yes. What if I had that right there? Still 3? Yes, you agree with that? Well, still 3. It just so happened that when I measured, that ended up being a 0, and that ended up being a 0, and my device was accurate enough to measure in that detail. That's still 3. Okay? Let's go back to here. I usually write down small, either above or below. How many sig figs in the second number? I'm going to round to 3 sig figs. Do I do any rounding before I go to my calculator? So I'm going to type this in as is. 1.63 times 2.5719. How many sig figs? 3. So the third sig fig, 1, 2, right there, that 9. Is that 9 going to stay a 9 or become a 0? 4.19. I can even give it to you in scientific notation, which makes the multiplying and dividing part easier. Believe it or not. Supposing I had 6.357 times 10 to the 4th, 2 times 10 to the 7th, divided by 5.0 times 10 to the 12th. Instead of 12th, just for giggles, make it 14th. That'll make this question a bit harder, which will actually be better for us to learn from. That first number in brackets, how many sig figs? That second number, yeah. Can you ever have 0 sig figs? Zero sig figs would mean no data. So you can't ever have zero. You always have at least one. Good question, though. How many sig figs on the bottom? Not one. Two. So here, when we did unit conversion, we typed times 10 to the power of. Here, this is scientific notation. I strongly encourage you, use your scientific notation button. Is this a fraction? Is there more than one thing on the top? I'll put the top in brackets. Is there more than one thing in the bottom? Then I'm not going to put the bottom in brackets. Quickly one. 6.357 scientific notation button 4 time, and I've told you don't represent multiplying using two brackets like that. Easier to read in handwriting. That's way tougher to read on a calculator. So I replace on my calculator two side-by-side brackets with times. I just put a big uber bracket around the top, and if I need to, and a big uber bracket around the bottom if I need to. So times 2 divided by 5 points. I don't think the 0.0 makes a difference. I'll put it in there just so I don't creep you out. I get that. You get 0.002548? Yeah. Yeah. Now, how am I going to write that? How many sig figs? One sig fig is right there. Is that 2 going to stay a 2 or become a 3? And so, I would either write 0.003 or, because this is right around the tipping point of scientific notation, 3 times 10 to the negative 3. Is that okay? Adding and subtracting is a tougher one. Now here's the good news. On your quest, on the sig fig questions, it's probably 70-30%, 70% multiplying, dividing, 30% adding, subtracting, because it turns out you'll find in physics most of what we're doing this year is going to be multiplying and dividing. So, okay, I kind of slanted that way. So let's do some adding and subtracting. 12.613 plus 4.27198 minus 4.6. Now, initially in the lesson, hang on, I'm going to pause for a second.
Good morning, everybody. It's time for our flex announcements.
When I first taught this to you, we wrote these vertically, and I said you round off until you have a column where you're missing numbers. There's a shorter way to do it, and I've debated teaching only that method. The shorter way to do it is to say, how many decimal places does this number have? Not how many sig figs. I know it's 5 sig figs. How many decimal places? How many decimal places? 6 sig figs, but how many decimal places? How many decimal places? I'm going to round to 1 decimal place. And you'll notice I didn't say sig figs, I said decimal place. Again, I type this into my calculator as is. 12.613 plus 4.27198 take away 4.6. I'm going to round to 1 decimal place, which is going to be, is that 2 going to stay a 2 or become a 3? So the final answer is 12.3, and I want you to notice how many sig figs does 12.3 have, which doesn't show up anywhere. There's no 3 sig figs in the original question. Adding and subtracting, it isn't sig figs, it's decimal places. And the reason we're doing that, by the way, is we're saying, look, whatever measuring devices you were using, apparently this device here was so bad that every number coming after it is a wild guess anyways, so how can you bother including that extra data? It'd be a guess anyhow. And the sig fig rules were designed or invented to help you figure out how to compare measurements of different accuracies. The problem we're going to have this year is all of our equipment is so bad, technically we should do everything to 1 sig fig, which gives us just stupid data. What's the answer? 10 for everybody, because it's 1 sig fig. So we'll ignore a lot of our sig fig rules when we're doing our analysis, just so we can get more meaningful data, even though we know that the meaning is bad accuracy. Okay. That help a little bit? You want to try working on the review and on the take-home quiz and whatever on your own? The only thing I didn't do is scientific notation with adding. I'm leaving that on purpose for you to see if you can have that aha moment and figure it out. There's going to be one question where you're doing adding scientific notation with sig figs. Your hint is unscientific notation it, turn it into something like this.